Let's go over the sample test we had. So the first one is we got this polynomial, and so I'm going to type it into my calculator, which I've already done, and then I'm going to go zoom for and take a look at it, and it says, looks like it goes through 0, and it looks like it bounces at 2. So I'm going to say this is a multiplicity of 1 because it went straight through. And I'd say this one is a multiplicity 2 because it bounced. So that's 1, 2, 3 of the 5 possible zeros. Let's see if we can find the rest of them. So if 0 is one of the zeros, that means there's an x in all this, and so I can factor that out. So f of x would be x times 2x to the 4th minus 8x to the 3rd plus 18x squared minus 40x plus 40. And now I want to see if x minus 2 goes into all this, but I could do long division, but I'm going to do the synthetic, which is 2 goes into, now I got to make sure I get all of my x's. My degree is 4, so I'm going to have 2x to the 4th, negative 8x to the 3rds, x to the 2nds, I've got 18, x's I have negative 40, and then the constant is 40. And if 2 is a 0, that's what I put here. And I add down, so 2 plus 0 is 2, multiply, add down, multiply, add down, multiply, add down, multiply, and I get 0. So it went in evenly. But I think it should go in twice because it was a bounce on the graph, meaning it's a double. So I'm going to try to put 2 into the remainder here and add down, multiply, add down, multiply, add down, multiply, add down. It went in evenly twice. So I factored out the x because of the 0, and then I was able to do synthetic division with 2 twice because it was a double 0, and now I'm down from x to the 5th, take out the x, I'm x to the 4th. Dividing once, that makes it x to the 3rd. Dividing again, this is x squared plus 0x plus 10. So I'm trying to solve now 2x squared plus 0x's plus 10. When does that equal 0? Well, I can put that into the quadratic formula. B is 0, A is 2, C is 10. But since there's no x term, I can just subtract 10 from both sides and say 2x squared equals negative 10. Divide by 2, and I get x squared equals negative 5. So x is going to be the square root of both sides. It's going to be plus or minus the square root of negative 5, which means it's plus or minus the square root of a negative is I, square root of 5. So one of my roots is I, square root of 5. And one is negative I, square root of 5. They're both singles, and they're imaginary. So, what's my polynomial look like factored? So we know it had an x minus 2 twice, and an x minus I square root of 5 for the plus one, and x plus I square root of 5 for the minus root. And if I multiplied this together, I'd get 1x to the fifth, but this had 2x to the fifth, so I need a 2. And so that would be the factored form. And I've completed the table with exact values for all the roots. So what's the y-intercept? Well, I can use this and plug 0 in down here, but it's a lot easier to plug 0 into here, and 0 plus 0 plus 0 plus 0 plus 0 is 0. So my y-intercept is when x is 0, I get 0. Y-intercept's a point. I'm going to be picky about that. Give me the x and y coordinate. The x-intercepts. Well, that's putting 0 in for the y, and one of them is at 0. A double one is at 2, and these two are imaginary intercepts, so I don't show them. There were just 2 x-intercepts as we saw on the calculator, 0 and 2. What's the end behavior? Well, degree 5, they go in opposite directions, and if it's a positive, this end is down and this end is up. Do we have any local maximums? Well, this thing is going, move it over here where you can see it. It's going up and it comes down and goes back up. So it's got a maximum somewhere between 0 and 2. So on a calculator, we say, second, calculate the maximum that's somewhere between 0, enter, and 2, enter. And I think it's about 1, enter. And it says, no, it happened at 0.75, about 3/4. But the maximum is 13. 0.7. 0.37. And that's happening at x equal 0.751. But I'm going to this is the maximum right there. That's the answer to this one. I'm just making that note so that I got it for later. Is there a minimum? Well, yeah, this thing comes down and touches at 0. So the local minimum is 0. And I'm going to make a note to myself. It happens at x equal 2. When is this function? One of the y values, for what x's are the y values less than or equal to 0? Looks like it's less than or equal to 0 all the way up for x's here, all the way up to 0. This graph goes on down and down and down. So from negative infinity, x's up to 0, and it is equal to 0 at 0, so I'm going to include it. Union, there's one other place, and that's at 2. So I'm going to say from 2 to 2, including the 2's. That's a very small interval, 2 to 2. The book will allow you to go just 2 for a single value like that, but I do from 2 to 2. Determine the intervals where f of x is decreasing. Okay, so this thing was increasing up till the maximum, and then it decreased. Well, the maximum had happened at x equal 0.075, so at 0.751, that's when it hits the maximum. The maximum is not increasing or decreasing, it's where it's changing. It decreases all the way over till x becomes 2. At 2, it's changing, so we don't include. and that's when it's decreasing. So it's increasing from negative infinity up to there. It's increasing from 2 to infinity, but it's decreasing from there to there in the x values. Okay, that's page 1. Page 2. Suppose a punter for a football team wanted to have a hang time of 5.4 seconds. So we want a parabola that the ball comes back down at 5.4 seconds and goes up at 0 seconds. So that means the parabola must have the t and t minus 5.4 to hit there and there. And if we're doing this in meters, it has to be multiplied by the number that for gravity, half of gravity in the meters per second, which is negative 4.9. And so that's the model for how high the football would be at any time t. Negative 4.9 times t squared, and then negative 4.9 times negative 4.9 t times negative 5.4. But that's what has to be the parabola. Determine the height in meters that the football would have to be kicked to. So now we can calculate the max. Let's write this worked out. That's negative 4.9 t squared. Minus is plus, and 4.9 times 5.4 is 0.05. Let's see. That should be 4.9 times 5.4. Oh, I did subtract times. Wondered, that didn't look right. 4.9 times 5.4 is 26.46 t. And the height, when it's at the highest place, is at minus b over 2a. That would be the time that it's at the highest. So that'd be minus 26.46 over 2 times negative 4.9, which is negative 9.8. If I divide that, I get 26.46 divided by 9.8, and they're both negative, so the answer is positive. 2.7 seconds, which I could have guessed. If it's 5.4 seconds for the whole thing, half of that time it will be going up, half the time coming down, so it's half of 5.4, which is 2.7 seconds. That's when it's at the highest, but to find out how high it is, I have to put 2.7 in for the t's. So I can do that, or I could have just graphed it. I could have said negative 4.9 x squared. Actually, I could have graphed it simpler. Parenthesis x minus 5.4. Could have graphed it in its original form. Here it goes up, and then it came down. Happens somewhere between 0 and 5.4. We think it's at 2.5. We could just find the value at 2.7 seconds. And it says it's at 35.72 meters. That's plugging 2.7 into the equation. Or I could find that also by going second, calculate the maximum somewhere between 0 and 5.4, and I think it's about 2.7, and it says, yeah, it's at 2.7, it's 35.72. And this is in meters high. Find the average velocity between 2.3 and 3 seconds. Well, average velocity is the change in the distance. So we have to find where it is at 2.3. So I can go back to second, calculate the value at 2.3, and it says 34.937. 34.937. We got to take that from where it is. Second, calculate the value at 3. And at 3, it was at 35.28. So it's the change in the distance. So that it's 3 there and a 2 there, 2.3 there, over the change in time, which is 3 minus 2.3. And that'll give me a velocity average. This is going to be in meters, and this is in seconds. So I get 35.28 minus 34.937 is that, and then I have to divide it by 0.7. Divided by 0.7, and I get 4.49 meters per second is its average speed during this interval between 2.3 and 3 seconds. What's its average velocity just before it hits the ground? Well, it hits the ground at 5.4. At 5.4, it's got a height of 0. And just before that, let's just do 5.3 and see how high it is. So second, calculate the value at 5.3. So that's just before it hits the ground. It's at a height of 2.597. Plugging 5.3 into this equation. So the average velocity is the change in distance. So 0 at the end minus 2.597 over the change in time, which is 0.1 seconds. So that's negative 25.97 meters per second. It's negative because it's falling. Okay. Number 3, complete the square. So when we completed the square, we pull the leading coefficient out of the first two, so it's 2 times x squared minus 4x plus something minus something. And then leave the plus 11 on the outside. And then we write 2, and we go bracket something squared, so that's going to be x minus half of this, so it's minus 2. And negative 2 squared is 4, and minus 4. These 3 is what this is squared. So we still have a minus 4 that's in this brackets, plus 11. And if we take the 2 times this, we get 2 times x minus 2 squared. And the 2 times that is, that negative 4 is negative 8 plus 11 is plus 3. So The vertex, well, this parabola is moved +2 and up 3. So there's the vertex. And the axis of symmetry or center line is at 2 because this is moved over 2. So it's at x equal 2. X equal 2 is a vertical line, and that's the center line or axis of symmetry. It's an equation. You need to write it as an equation. It'll be an x equal. Okay, number 4. Ranchers making 3 adjacent pens using 500 feet of fencing. So it's got to do this side, this side, this side, and this side. And it's got to do this side, this side, this side, this side, this side, and this side. And I don't know if they're going to be squares or not, but I know that the 500 feet has to cover 4 x's and 6 y's. And I'm supposed to maximize the area. Well, the area is x times 3y. Now, if I want to make this a function of just x, I'm going to solve for y. So if I solve this for y, I'm going to subtract 4x from both sides. And then I'm going to divide by 6. And I get the area, or I get y is equal to 500 minus 4x over 6. And if I put this in for y, I get x times 3 times 500 minus 4x over 6. And this is what I want to maximize. Now I can type it in just like that, or I can simplify it. 3 goes into 6 2 times. So it'd be x times 500 divided by 2 is 250. And minus 4x divided by 2 is minus 2x. That's a little simpler to type in, but I could have typed the other one in. So I'm going to clear this, and I'm going to go x parenthesis 250 minus 2x and graph. And it goes through 0, which we expected, and it must go through something way out here. What makes this 0? 125. So I need to change my window, so I'm looking at big X's. Let's say 200. Went up and came down. And so the max must be somewhere in the middle of this. This is 200, so this is like 100, so this is like 70 something. So I'm going to go second, calculate the maximum between 0 and 150. And my guess is 70-ish, and it says it's 62.5. Now I could have also gotten, let's see, and the maximum, the actual area is 7812.5 square feet. But that's the X for this one. 62.5 feet. What's the Y? Well, I'd take 4 times that, so 62.5 times 4, and I get 250 feet. 250 feet from 500 is 250 divided by 6. 250 divided by 6, and so that means the Y is 41 2/3 feet. 41 2/3 for each of the y's, and 62.5 feet for each of those would make the maximum area of the pens. Okay, next page. Divide these. Well, we're going to do long division. So we got 6x to the third plus 21x squared minus 6, and we're dividing it by 2x squared minus 5. So 2x squared times what makes 6x to the third? Well, I'd have to multiply by 3 to get 6, and I'd have to multiply by an x to get x squared to be x to the third. So I'm going to do 3x times 2x squared, and I get 6x to the third. 3x times minus 5 is minus 15x. And then my saying is, draw the line, change the signs, so we can add like terms. These are like terms, they add up to be 0. These are not like terms, so I get 21x squared plus 15x minus 6. 2x squared times what is 21x squared? And I think that would be 11.5. 11.5 times 2 is 21. No, 10.5. Excuse me, 10.5 times 2 is 21. And 10.5 times 5 is negative 52.5, I believe. Just check my arithmetic. 10.5 times 2 is 21, and 10.5 times 5 is 52.5. And that's negative, so it's negative 52.5. Draw the line, change the signs, add, and I get 15x minus 6 plus 52 is plus 46.5. X squareds won't go into this, so this is my remainder, and my remainder goes over what I was dividing by. So I get plus 15x plus 46.5 divided by 2x squared minus 5. Synthetic division to solve this. Well, if it's x plus 4, the root is negative 4, so I got to put negative 4 into, and I got to make sure I have all of these. So I have x to the fourth, I have 1x to the fourth. How many x to the thirds do you see? Yeah, I don't see any either, so I have to put 0x to the thirds. How many x squareds? Well, negative 3. How many x's? 2, and the constant, negative 5. Add down, multiply. Add down, multiply. Add down, multiply. That's at negative 52. Add down, multiply. Add down. So it doesn't go in evenly. So my answer is, see, this was x to the fourth, so this is x to the, I get 1x to the third minus 4x squared plus 13x minus 50 plus my remainder over my divisor. The remainder goes over the divisor. Like we did up there, we get it here. A 5-degree polynomial that has plus and minus 2, so that means that has to be x. For the plus 2, it's minus 2. For the minus 2, it's x plus 2. For the minus 5, it's x plus 5. For this complex number, it's x minus this, so it's plus 1 minus 2i. And if you got an I, then it has to have the conjugate, so it's going to be x. The conjugate to this is minus 1 minus 2i. The I part, or the square root part, is the one that changes sign. And then I have to subtract that, so it's plus 1 plus 2i. And that's a fifth degree polynomial. Don't have to multiply it out. Okay, going to analyze this one by looking at the graph. So it bounces at, let's see, 3 would make this be 0, so it bounces at 3. Now, I'm not sure, let's see. Negative x squared is going to be an x squared times a negative x times an x. So that's going to be negative x to the 4th. So both ends are going to be down. And let's see, it's got to cross at plus 1. It bounces at 3, and it crosses at negative 2. So if it's coming from down, it's got to cross there, go through there, and then bounce. And I want to know when the y values are greater than 0. Well, it looks like it's greater than 0 from minus 2 to 1. Not including those, because at those places it's 0. And this is all less than 0, so that's the answer, from minus 2 to 1. Or if you will, x such that minus 2 is less than x, which is less than 1. And finally, write a polynomial that looks like this. Well, if it goes through minus 4, straight through, x plus 4 has to be a factor. If it goes straight through at minus 2, x plus 2 has to be a factor. And it looks like it does come down and hesitate, then go on at 3. So I'm thinking it's x minus 3 cubed. And it's supposed to go through 4 on the y-axis. So there's got to be an a here that makes this have a value of 4 when x is 0. If I put 0 in here, I get 4. If I put 0 in there, I get 2. If I put 0 in there, I get negative 27. And I'm supposed to have 4 for an answer. So I divide by a 4 and by 2 and by negative 27 to get rid of that. The a that goes here has to be, the 4's cancel, 1 over negative 54. So my answer is negative 1/54 x plus 4 x plus 2 and x minus 3 to the 3rd.